Software Engineering Radio, Episode 11, interview with Gregor Kiczales. Hi everybody and welcome to this new episode of Software Engineering Radio. This is another interview episode, and this time we have the great pleasure of interviewing Gregor Kiczales. He's one of the fathers of aspect-oriented programming. Back in the days when he was still at Xerox Parc, he and other folks worked on aspect-oriented programming as well as on some of the forerunners, for example, meta-object protocols. He's also co-author of a book called The Art of the Meta-Object Protocol, where he and his co-authors explain how meta-object protocols work. This is really interesting reading. Today, he's a professor at the University of British Columbia in Vancouver. I met Gregor at the AOSD 2006 conference in Bonn, Germany. Note that we had some kind of a problem of finding a quiet spot in the conference venue, so the sound quality is not always that good. So welcome, Gregor, to this show. Why don't you explain your personal background and your involvement in aspect-oriented software development?
Hi, thank you very much. It's a pleasure to be here. I guess my work on aspects goes back quite a ways. We, in some sense, we started working on some of the precursor ideas when we were working with reflection and meta-object protocols, even in the mid-'80s. And then in different ways, that work led us to start working on the idea that we now call aspect-oriented programming through the mid-'90s and right up until today.
So if we look at the history, specifically meta-object protocols and stuff, what is the relation between the two? Some is obviously more dynamic, the other is more static, typically at least. So how do you see, or how do you explain, or how would you see how one developed from the other? What's the relationship there?
Well, with meta-object protocols, there were really a lot of different things going on. Three in particular is that with meta-object protocols, you have language extensibility. You have meta-level shift, which is more intellectually interesting than, at least in the context of meta-object protocols, is primarily intellectually interesting. And you also have modular implementation of cross-cutting concerns. And I think when we were winding down the work with meta-object protocols and starting to look at some of the problems with making large, efficient, flexible systems, we really started to focus on which of those properties of meta-object protocols was doing the most work for us. And I think that's when we really began to focus on this notion of modular cross-cutting. At the time that we did the meta-object protocol work, we didn't call it modular cross-cutting. But we really, I think, and this was in the period sort of in the early 90s, mid-90s, really came to understand that this notion of cross-cutting structure and modular cross-cutting structure was important. And then with AOP, I think that what we did was to really focus on that, and in particular, AOP languages like AspectJ give you the ability to modularize cross-cutting concerns without having any meta-level shift and without having language extensibility. They really focus on that particular issue.
So some people say, maybe the more critical people say, that aspect orientation is something that has been there a long time. It has just been called using interceptors or using proxies, factories, and interceptors. So how do you see the relationship there? Is AOP to some extent kind of refurbished interceptor thing, or are interceptors an instance of the more general AOP or AOSD thing?
Well, I mean, that's a good question. I think it's actually several good questions. One question is interceptor-based programming AOP programming? And another kind of question is, which came first? I think the first question is in some sense more interesting. The main problem of any, or the main goal of any programming technology is to solve problems and to make systems in some way higher quality, make them run faster, make them cheaper to develop, make them more fun to develop, make them more configurable, solve some real problem. So the first thing to say about interceptor-based technology is that if in a particular system it solves the problem that you need solving, then and that's what matters. That said, I think that one way of looking at using interceptors is that it provides you a kind of coarse-grained version of the same kind of functionality that you get with point cuts and advice in a language like AspectJ. So there's a similarity there, but each of those words in that sentence is carefully chosen. It's coarse-grained in the sense that with the point cuts and advice of a language like AspectJ, you get much more fine-grained join point model and the ability to cross-cut things at a much more fine-grained level. The other thing that you get in a language like AspectJ is you have a linguistic model for it, so you get all kinds of composition properties that you don't get in most interceptor-based approaches. And you can also get things like static checking and radically more efficiency than you get in an interceptor-based approach. So I think what you see is that, maybe one way of thinking of it is that people use interceptors to do a kind of ad hoc version of handling cross-cutting concerns. And if that's good enough for the problem at hand, then that's good enough for the problem at hand. And then people who have problems that require sort of a more systematic use of modularizing cross-cutting concerns are going to need to go to a more systematic and well-engineered sort of tool, and maybe that's going to look less interceptor-based.
There is this question whether you might think that AOP is more important on this fine-grained level of programming languages, where also some people say this breaks encapsulation and therefore isn't good, or whether AOP is more important on an architecture level. So you use components, containers with interceptors, and some people say that's actually more valuable because it's a more specifically defined join point model, basically, instead of being able to mess around with Java, as some people might say. So do you have an opinion on that?
Well, I think it's important at both levels and just in different ways. We could come back to the encapsulation question later. I think that if you look, for example, at the way AOP works in something like the Spring framework, you've got relatively coarse level. It works on the container invoked calls, and they get a tremendous amount of value out of that. I think if you look at the way that some people program with AspectJ, where they write very fine-grained point cuts, or they write a point cut that matches against 1 million lines of code that somebody else wrote, and that solves a problem for them. I just don't think it's. I just don't think the way to look at it is whether it's more important in one domain or the other. It's important in both domains to deal with cross-cutting concerns. I think the real contribution of aspect-oriented programming, 10 or 15 or 20 years from now, is going to be that we gave a name to a problem that had been around for a long time, but a community of people, the people working that I was working with at Parc, but also many other people, collectively finally got clarity on this problem of cross-cutting concerns. And that problem happens at all sorts of different scales and in all sorts of different systems. And like any other such problem, there's going to be different technical solutions to it in its different forms. So I really think the main issue here is coping with cross-cutting concerns in a modular way. And a language like AspectJ does that very well at certain levels of granularity, and something like the Spring AOP framework does it very well at other levels of granularity. And I think we're going to see much more macro versions of the technology as well as we come to understand it better.
So do you want to come back to the breaking the encapsulation thing that some critics, you've probably answered that 5 million times, but just for completeness.
Okay, so the AOP breaks modularity question. My answer to that is simple. It doesn't. It not only doesn't break modularity, it improves modularity. Now, so the question is, why is it that people can say that it does break modularity, and I can say that it doesn't break modularity? And let's just stipulate that neither of us is crazy. The answer really is that the existing kinds of modularity enforcement mechanisms, the encapsulation mechanisms we have, technically they do the job that we say they do. But if you look at what actually happens in software practice, the current mechanisms force people to go around them all the time. So we've shown in a number of examples, there's for people who like to read this kind of academic paper, there's a paper that I wrote with a colleague, Mira Mazzini, from Darmstadt, in which we basically showed that for a very simple example, what will happen is that the developer will have to go around the modularity mechanism and go scatter code all around. So you can say that the old modularity mechanism enforced modularity, but the social practice went around it. And so what AOP in some sense is doing is it's trying to be true to what's actually happening. I think that was one of the fundamental things that we at least were working with in the group at Parc. You know, we were sitting there at Parc down the hallway from the ethnographers and hearing them say, look, it's not enough to just listen to the story people tell about technology. You have to go see what's actually happening in practice. And I think that's part of what's helped us get this insight that, you know, you can tell me that Java provides strict encapsulation, but if what all the programmers are doing is violating that encapsulation, then in fact, it's not really doing the thing you say. And I think if you look at AOP programs, you get a modularity that is more natural, and so the way people are going to work with it is going to be more natural. You know, that's why sort of both people are right. The old languages had this modularity enforcement mechanism. AOP has a different modularity enforcement mechanism. But the old languages weren't really giving you the modularity that they said because people were sort of systematically punching them in the nose all the time.
So you already talked about the practical relevance of AOSD or an AOP. So what do you think about the acceptance of aspect-oriented programming in 2006 by the industry? Is it as you expected? Is it running better as you might have wished? Or what's your opinion on that?
I think it's running incredibly much better than we could possibly have expected. Right now, if you look at sort of the enterprise Java space, and you look at frameworks like JBoss and Spring, you know, the fact that those frameworks are built in part using aspects, of course they use lots of other technologies, but the fact that those frameworks are built in part using aspect technology, and that in fact aspect technology is an important component of how they're built, you know, is really quite incredible. I mean, I don't have the exact numbers off the top of my head, but frameworks like JBoss and Spring have a huge number of users. You know, big banks, lots of big companies. I mean, they're just standard development technology. And here they are using this aspect stuff, which, depending on when you want to say aspect started, is less than 10 years old. That's not the normal life cycle of true innovations in software development. You know, things that are truly new, things that are intellectually controversial, tend to take more like 20 years to work their way into standard practice. You know, people will say, well, no, that's not true. You know, technical innovations can be adopted very quickly. Look at how quickly Java was adopted. But that's quite different, right? When Java came in, it was a 6th or 7th generation of virtual machine-based object-oriented programming language. I'm not detracting from what Java is at all, but it was not intellectually controversial at the time that it came in. Whereas, as we were just talking about with the encapsulation thing, AOP was intellectually controversial and still is. So I just think that AOP is being adopted incredibly quickly. Clearly, enterprise Java is so far the space where it's being adopted most quickly, but couldn't have imagined it going more quickly. And I don't think anybody involved with it could have imagined it going more quickly.
So some people say that modularizing technical cross-cutting concerns like persistence, tracing, the usual suspects, persistence is rather easy and has been done all the time, therefore AOP is nothing new. And if you talk to more expert AOP community members, they will tell you that AOP can and should also be used to modularize cross-cutting concerns in business logic. So what do you think the state of the art is there? Is it a kind of accepted practice in industry to use AOP for business logic modularization, or is it still more or less at this technical cross-cutting level?
Well, I think again, if you look in the enterprise Java space, what's most widely accepted is to use aspect techniques for modularizing what I like to call the big A aspects, you know, persistence, logging, the generic things. Now, there's two reasons for that. One reason is people start by doing the things for which there are a lot of examples. When people first saw systems like Smalltalk, the first objects they made were always, things like windows and things that moved around on the screen, and lines and points and circles and stuff like that. Right? In fact, for a while, people used to think that what the object metaphor meant was that it was something that existed in the display on the desktop. Another reason why that's what people mostly do right now is that frameworks like Spring really are only supporting that kind of aspect. Right? It's a very well-engineered framework for supporting these coarse-grained aspects. That was really their design goal. And so people who start programming with aspects in that kind of context, A, there's examples to do that, and B, that's what the framework supports. So that's what they do. Now, if you look at what people who program with Aspect-J do, they tend to start writing aspects like that. Actually, the most common scenario is to start by writing debugging and architecture enforcement aspects. But then they gradually move to writing aspects sort of systematically throughout their application, wherever it makes most sense. So those end up in core business logic. They end up wherever there's a cross-cutting concern. What there's absolutely no doubt about is that there are cross-cutting concerns that are in the business logic. There are cross-cutting concerns that have very small range. There are cross-cutting concerns that are these so-called technical or systemic things that have very large range. There's nothing about the idea of cross-cutting that restricts it to any particular kind of concern. It's not cross-cutting. One of the I think the most common misconceptions about cross-cutting is to try to equate it with something. So people will say, well, cross-cutting concerns are the optional concerns. That's not true. Cross-cutting concerns are the non-functional concerns. That's not true. Cross-cutting concerns are the, computer science-y concerns. That's not true. What cross-cutting concerns are is they're cross-cutting. And some of those things have cross-cutting properties, but lots of other things too. I'm actually writing a little compiler right now in Aspect-J, and in the code generation phase, the code generator needs to make sure that it's properly emitting code that properly respects stack discipline. And I have a little aspect that cross-cuts the entire code generator that just keeps track of making sure that the generated code enforces properly respects the stack discipline. I could have written that code in another way, but when I write it as an aspect, it's really beautiful code. It's not persistence, it's not synchronization, it's not anything like that. It's a core part of making sure that my compiler is generating correct code.
So let's maybe briefly look at some of the other hype technologies today. One is certainly scripting languages, dynamic languages. The other big thing currently is certainly model-driven development approaches. So I'd like to hear your opinion on how AOSD and AOP specifically relates to these approaches. Some people say you don't need it in Ruby because you just, you change something in the class definition, or you use runtime code generation or some reflective means to do the same stuff. And some people say that in model-driven development you don't need AOP because you can let your generator handle some of the cross-cutting aspects. So do you have any enlightenment on these things?
Well, again, I think the way to think about the answer to these questions is to go back to the point I made that what's really important about AOP, AOSD is this focus on this notion that there are cross-cutting concerns and that there's a family of techniques for modularizing them, the so-called join point models. Now, why am I going to that level to answer your question? It seems like I'm making the question more complicated rather than simple. But actually, here's why. Let's look at modeling. And let's look at a fairly standard modeling language, the UML, and simple things like state charts and class diagrams and sequence diagrams. When you take the perspective of cross-cutting concerns and join point models to modularize them, what you immediately see is that one of the reasons why the combination of class diagrams, sequence diagrams, and state charts is such a powerful tool in UML is that in fact those three diagrams cross-cut each other. The combination of the three diagrams allows you to modularize important kinds of cross-cutting concerns at the model level. So what that says is, and this should not come as a great surprise, is that there were already ad hoc solutions to parts of the problem of coping with cross-cutting concerns. And we knew that. What it also says, and we've done this as a project at UBC, is that you can reconstruct the kinds of mechanisms that exist in things like the UML explicitly in terms of joint point models, and you actually get a little bit of additional power there. So, so the question is, well, you don't need aspects if you're doing modeling. I just don't think that's right. I think what is the case is that modeling tools already have aspect-like functionality in them. And by recognizing that from both perspectives, both from the aspect camp and the modeling camp, we can just do a better job of achieving modularity at the model level. I think it's also fairly clear that there will be times when you want your modeling tool to generate code in an AOP language, and there will be times when you don't want your modeling tool to generate code in an AOP language. As you can see, I try to avoid giving sort of categorical answers because I think that all these things are really engineering decisions, and that engineers have to make the right decision at the right time. And I don't like the way so much of the way technical stuff these days is sort of ends up being hyped as the ultimate solution. None of these things are the ultimate solution, but all of them used together can be very powerful solutions when you use the right one at the right time.
Yesterday in a workshop here at the AOSD conference, we took several notes on the flip chart, and one of it said, think AOP, which we kind of said is more important than use AO programming languages. Hearing or listening to what you're saying, you would probably agree to that.
I'm not sure I think it's more important, but I think it's as important. Certainly one adoption paradigm for aspects is to think aspects and still write old-fashioned code. One of the things that a number of us have advised people to do is if you hear a lecture about aspect-oriented programming and you come away excited, but you can't change your programming language today, there is a thing you can do, which is that you can realize, hey, I'm struggling with a cross-cutting concern here. And you can write some pseudo aspect J code in a comment. And then you can go scatter that code manually. And yes, in some sense your code is no better than it used to be because it's still scattered and tangled. But in fact it is much better because now there is a crisp definition of how it got scattered. And actually if you go back to sort of the early days of the object idea, what a lot of people did is they saw the object idea, but they didn't have a language, and they just started programming little vectors of methods that they passed around. And that was kind of like something they were already doing. But because they now had an intellectual idea with which to organize it, they did it in a little bit more disciplined a way, a little bit more principled a way, and their code got better. So I think if you're going to program in aspects, you absolutely have to think in aspects. And I think that if you can't program with an AOP language, you can get a lot of benefit by just thinking in terms of aspects. Certainly what's true is, to really get your head around this stuff, it is going to take some time thinking in terms of it. So you can start before you start programming in terms of it.
So to kind of sum up the practical discussion about the practical aspects of AOP, are there any standardization efforts for AO languages? Obviously, this is probably then specific to the base language. So is there anything, standardization efforts for example, various Java AO extensions? Or are there standardization efforts in other languages?
Well, I think on the Java side, what you're seeing is sort of a de facto standardization process that's emerging. 7 years ago, we had one language, Aspect J. And 3 years ago, we had 3 or 4 important tools. There was Aspect J, there was Aspect Works, there was the Spring AOP framework, and the JBoss AOP framework. Today what we've seen is that Aspect Works has merged back into Aspect J, and now Spring, the lead developer of the Aspect J project, now works for Interface 21, the company that supports Spring. So Spring has the plan to continue to use its own framework for the coarse grain aspect stuff, and to begin using Aspect J for fine grain aspect stuff. So really, you've got kind of IBM BEA and Spring on top of Aspect J and the Spring framework. So I think there's a pretty strong de facto standardization there. All of that seems to really be driving in the Aspect J direction. On the .NET platform, I don't think there is yet a clear de facto standard there. That's sort of a different platform because at the end of the day, Microsoft is going to have to make a move. There's some rumbling that is at least beginning to be thought about. My personal opinion is that it's too soon to even think about something like a JSR for AOP-like functionality in Java. When you've got a strong enough de facto standard, but you still have a little bit of competition in the space, I think that's good for the technology. I don't see the need to put it in a JSR that would not have, that would make it difficult to improve over the next 3 or 4 years. At this point, I don't hear people say that the reason they're not adopting AOP is that there's not a clear standard. I'm sure that's true for some people, but at this stage of the adoption cycle, I don't think that's a dominant factor. And so I personally would not encourage something like a JSR or encourage other people to do so. But at some point down the road, something like that's going to happen.
So since we're at a more or less research conference here at the AOSD conference 2006 in Bonn, Germany, I think we should do some kind of excursion into the research part of AOP. There is various interesting things going on here. For example, what many people call early aspects. So that means using AO techniques in development phases before implementation. So this includes design, modeling, not refactoring, requirements, and these kinds of things. Can you give us a little overview of what's going on there and maybe where AOP research focuses these days?
I mean, I think what you're seeing is at this point, we as a research community just understand a lot more about what it means for a software technology to be mature. And so you see people trying to move much more quickly from kind of just having a programming language to having design tools and having design methods and having verification techniques and having testing techniques and all the way to having requirements and analysis techniques. And so what researchers who specialize in each of those subfields are doing is they're sort of trying to look at this idea of modular cross-cutting through join point models and understand how it plays in their space. Since we started with programming languages, clearly the programming language work is the farthest ahead. It's the stuff that's most production ready. But these other areas of work are coming along tremendously fast. And the vendors, or at least the big vendors, are being asked by their customers for answers to some of these problems. And I think what some of the researchers are hearing from companies that fund research is a real interest in answers to some of these problems. So really, there's just great research going on right now in all of those earlier stages of the life cycle in working with aspect-like ideas. And I think we're gonna see tools, methods, processes, and techniques come out of all that will be useful for people that work that way in the near future.
So again, for the practitioners, which is probably most of our listeners, do we have some best practices of how to pragmatically adopt AOP in projects? I mean, let's assume we have an AO language like Aspect-J and we are allowed to use it by our, central IT strategy department. So what's the best process? How should people go about introducing AOP?
Yeah, actually, I do have an answer to that. And the answer actually starts by not assuming that you have approval to do so. What we've done actually is that sort of kind of a consortium of the leading consultants in the Aspect technology space have really agreed with each other to adopt a strategy of trying as much as possible to not overhype the technology and to encourage people to go slowly. And so we kind of have this 3 or 4 step process. It depends a bit on exactly how you break it down. But the first step is to do what we call development aspects. And what development aspects mean is that you use them on your desktop and they don't get committed to the main project's code repository. So development aspects include things like your private tracing aspects, your private performance monitoring aspects, your private debugging aspects, things like that. And they also include architecture enforcement aspects. Architecture enforcement aspects are things that let you sort of do things like define a certain layered architecture for your system and use aspect technology to ensure that you follow that architecture. What's important about development aspects is two things, or I guess three things. One is they're easy to start incrementally. Two is they're not committed to the main code repository. They don't ship in the running code. So they have what we call the you can use them without telling your boss property. Or more importantly, they have the you can use them without telling the build manager property. And what's important about this is it means that you can spend a month or 2 or 3, however long it takes, to really start to understand the potential value of aspects in your product before you have to take on the challenge of convincing somebody else, hey, we should use this in the product. Because otherwise you wind up in one of these impossible conversations where you say, hey, I read this great article about this aspect technology, we should use it. And your boss says, what's it going to do for us? And you say, I read this great article about aspect technology, we should use it, right? I mean, your boss wants to know what's it going to do for you. And so if you take this first adoption step, you can really start to get answers to that question before trying to convince people. And then what happens in the second adoption step is you have just a few developers programming with aspects, and they're writing those infrastructure aspects, things like persistence and logging and security and ... And so you're starting to spread it out, and the aspects ship in the product, but you've still restricted it to a subpart of the development team. And then in the third stage is really when you start to sort of let aspects be used wherever in the business logic makes most sense. And what we found is that people who follow this incremental process tend to be successful. Their AOP adoption tends to be successful. They really reduce their risk because if you get partway into that first stage and it's not working for you, then you drop the code you've written, you throw it away, and yes, you lost some time, but you haven't messed up the rest of the code base. And that seems to be really important. The other thing we find is that when we tell people to follow this process, they all say, okay, yeah, we'll do that, and we'll do 3 months in the first phase and 6 months in the second phase, and then we'll go to the third phase. And they all end up going faster. But having this staged process seems to be important. And if you look at a lot of the things that people have written on their blogs, like Adrian Collier's blog or the IBM Developer Works AOP at Work series, they detail this process in much more detail. There's a very good article in that series about this staged adoption process.
Okay, and we'll put some of those links into the show notes so you can easily find them. Okay, that wraps up my questions. And since we can't have listener questions interactively, obviously, for the obvious reasons, Gregor, anything else you want to add to kind of, clarify something that you always wanted to say or anything else about AOSD?
Well, no, I would just say, I guess, thanks for listening. And, try this stuff out. It's fun. It makes your code look good. And at the end of the day, good-looking code that does what it's supposed to do and is flexible and is fun to write is a good thing.
Okay, thank you. This was another episode of Software Engineering Radio. The Software Engineering Radio team wants to thank Henning Pauli for providing the music, as well as Libsyn.com for hosting and bandwidth. For more information on the podcast, past episodes and feedback, go to se-radio.net.